friends, welcome to another session of engineering mechanics. In this session, we are going to start plane trusses. I should say this is one of the important chapters for GATE for both mechanical and civil engineering students. Many GATE questions already came from plane trusses. Again, many questions will come, no doubt. So be careful, and I should say it is one of the simplest chapters in engineering mechanics. This is simple and high frequency topic. Regularly in GATE, questions are coming from plane truss. Listen attentively and solve problems. Right. First I define what is plane truss. What is plane truss? I'm writing here. Plane truss. Right definition of plane truss. Let us try to understand what is plane truss. It is assemblage of bar elements. It is assemblage of bar elements which are connected by frictionless pin joints, and load is applied only at joints. Load is applied only at joints. So this is the definition of plane truss. So it is assembly of bar elements. What is bar element? So write down what is bar. So I am defining what is bar. Plane truss is made with bar elements. Write down what is bar. It is the element which carries. I am defining bar. It is the element which carries only axial force. It is the element which carries only axial force. Like this, here a bar element is there. This bar element carries axial tensile force, right? Another bar element could be there. It may carry axial compressive force. So bar element carries only axial loads. No transverse load. This is bar element. This is also bar element. But this is not bar element. For instance, it may carry axial load and of course transverse load. Maybe this is P1 and this is P2. This is P1, P2. So this is not bar element. This element carries both axial load and transverse load. This is not bar element. So this is bar element. This is bar element. If any element carries only axial load, that element is called bar element. Okay. So plane truss is made with bar elements. So all elements of plane truss carry either axial tensile force or axial compressive force. They don't carry any transverse load. They don't carry any bending moment. They don't carry any twisting moment. No other load will act on elements of plane truss. So all elements of plane truss only carry either axial compressive force or axial tensile force. That is the meaning. And one point I have to add to plane truss. In plane truss, all elements should lie in same plane. So the name itself is saying, in a truss, number of elements could be there. All those elements should lie in same plane in plane truss. If all elements don't lie in same plane, the truss is called space truss. So in truss definition, you may add this point. I dictated like this. It is assemblage of bar elements which are connected by frictionless pin joints and load is applied only at joints, and you add this point, and all members lie in same plane. All members lie in same plane. Okay. Next, I am going to define what is space truss. Space truss. It is the truss in which all elements may not lie in same plane. All elements may not lie in same plane. That is the definition of space truss. Now I am going to define frame. Okay, what is frame? Write down what is frame. It is the assemblage of bar elements. It is the assemblage of bar elements and beam columns. Beam, then column. Beam columns joined by any sort of joints, and load is applied either on joints. Load is applied either on joints or members. So in a frame, some elements could be bar elements, some elements could be beam columns. What is beam column? So first you write what is beam column. I am going to define what is beam column. Beam column. It is the element which carries both axial load and transverse load. Both axial load and transverse load. So this is an example of beam column. Usually beams carry transverse loads, bars carry axial load. If any element carries both axial load and transverse load, that element is called beam column, right? So in frame, some elements could be bar elements, some elements could be beam columns like this. Please copy this. This is beam column. It is an example of beam column. Right. And one more point, in frames, all joints need not be pin joints. Some joints could be pin joints, some joints could be fixed joints, some joints are welded joints, some joints are bolted joints, like that, man. All joints in frame need not be pin joints. The joints could be any kind of joints. That is the second point. And third point, in frames, load need not be applied only at joints. Some loads could be applied at joints, some loads could be applied at members. For instance, so here one truss is there, for example, right? So here this is a truss. If this is truss, all joints should be pin joints, and the load is only applied at pin joints. That means joints, man, right? You can apply load here, maybe P1. You can apply load here. This could be P2. You can apply load here, like this, man. In plain truss, all loads are applied at joints only. But what about frame? If it is frame, the load can be applied even on members like this. A load could be applied like this. This load is not applied at joints, it is applied on member. And another load could be something like this one, right? So in plain trusses, all loads are applied at only joints. In frame, load can be applied anywhere. You may apply load at joints or you may apply load on members. That is the difference. And if it is frame, all joints need not be pin joints. Some joints could be pin joints, some joints could be fixed joints like that. Okay? So this is difference between plain truss and frame. So in this class, we are going to discuss various aspects of plain truss. Okay? But before that, where you can find plain truss? Where you can find plain trusses? Generally, we find plain trusses in railway bridges, Bailey bridges. So in Bailey bridges, you may find plain trusses. In some machines also, you can find plain trusses. Where do you find frame? Frame is generally found in machines. Maybe it is found in cranes and in many structures, many machine structures. Right? Okay. So here I am going to start with plain truss. Plain truss. Okay. So first I try to classify plain truss. So plain trusses are classified into three groups. So first is rigid truss. Rigid truss. If 2j is equal to m plus 3, I can call this truss as a rigid truss or perfect truss. A rigid truss or perfect truss. Here, j is equal to number of joints. Number of joints, and m is equal to number of elements. Number of elements or members. Okay? J is number of joints, m is number of members. If 2j is equal to m plus 3, that kind of truss is called rigid truss or perfect truss. Rigid truss or perfect truss. Now you can easily understand here. J could be either positive or negative. See, J could be either even or odd. 2j is always even. J could be odd number or even number. 2j is always even. That means on right hand side also you have to get even. So already here 3 is there. How do you get even number on right? When m is odd number, then only you will get even number. Odd number plus odd number, you will get even number. So that means in all rigid trusses, number of members in truss should be odd. So write down this point. In all rigid trusses, number of elements is odd. ODD odd. Number of elements odd. So again I am saying either j could be even number or odd number. 2j is always even number. For getting even number on right, m should be odd. When you add odd number with another odd number, you will get even number. So number of elements in a rigid plain truss is always odd number, like 3, 5, 7, 9, like that. Okay? So this is rigid truss, man. And second kind of truss is over rigid truss. Over rigid truss. So in over rigid truss, 2j is less than m plus 3. M plus 3 is more than 2j. Then that kind of truss is called over rigid truss, or redundant truss also. Over rigid truss or redundant truss. So generally in over rigid truss, some of the members don't carry any load. Physically they present, but they don't carry any load. So like that. Then third truss is under rigid truss. Under rigid truss or collapsible truss. or collapsible truss. Under rigid truss or collapsible truss. So here 2j is more than m plus 3. 2j is more than m plus 3. When 2j is more than m plus 3, the truss is called under rigid truss or collapsible truss. If you apply any external load on under rigid truss or collapsible truss, immediately the truss will collapse. So under rigid truss or collapsible truss cannot carry any external load, man. We never design any under rigid truss or collapsible truss. If you apply any external load on collapsible truss or under rigid truss, immediately the truss will collapse. Okay. So these are the three basic types of plain trusses: rigid truss, over rigid truss, under rigid truss, or collapsible truss. Okay, please copy. So try to remember these three. Sometimes a truss will be given and you have to examine whether the truss is rigid truss or over rigid truss or under rigid truss. So that is the thing. So you have to remember these things. So in this truss, number of members is more than required. So here number of members are just required. Here number of members are less than required. Like that you have to understand, right? Okay. So let us try to examine few trusses, whether they form rigid truss or under rigid truss or over rigid truss. Over rigid truss. Okay. So here I am taking two elements here. These two elements are joined by a pin joint. So this is the first element and this is second element. These two are joined by a pin joint. So here J is equal to 1, M is equal to 2. Okay. Then what is 2J? 2J means 2. And what is M plus 3? M plus 3 means 5. M plus 3 means 5. So here 2J is less than M plus 3. Or I should say it is not rigid truss. It is not a rigid truss. You cannot formulate or you cannot form a plain truss with only two elements. It is impossible. Okay, to form a plain truss with only two members. So with only two members, it is not possible. Now let us think about three members, right? So here three members are there. Here one support is there. This is a pin joint. So here another thing will be there. Here also a pin joint. Here also a pin joint. This is A, this is B, this is C. Number of elements are 3. So here J is 3 and M is also 3. Number of elements is 3. Number of joints is 3. So number of elements is equal to number of joints. Okay. Let us think or let us examine whether it is forming a plain truss or not. What is 2J? 2J is equal to 6. What is M plus 3? It is also 6. So here 2J is equal to M plus 3. So it is forming a plain truss. So a plain truss can be formed by using three elements. Or I can say lowest number of elements in a plain truss is 3. Lowest number of elements in a plain truss is 3. So please copy. This is a plain truss, a rigid plain truss. All rigid trusses are called as plain trusses, man, right? So please copy and write these 2 points. So this is one joint, second joint and third joint. So number of joints is 3, number of elements is also 3. Here A, B, C are forming joints. Now write down this point. Lowest number of elements in a plane rigid truss, lowest number of elements in a plane rigid truss is 3. That is 1 point. Second point, in this truss, number of joints is equal to number of members, man. In any truss, if number of joints is equal to number of members, the truss is called whole truss. Okay? Write down next point. If number of elements equal to number of joints, if number of elements equal to number of joints in a plane rigid truss, the truss is called Howe truss. H-O-W-E, Howe truss. Maybe it is a name of scientist. Howe truss. Okay? So it is forming a truss, man. Generally in plane trusses, if you see the physical shape of the truss, it could be made with number of triangles, man. You can always observe number of triangles in a plane truss like this. Okay. Let us think about another truss, whether it forms a rigid truss or over rigid truss or under rigid truss. Just don't worry about this, man, right? Now, so I am forming a truss like this. So here one joint is there, here another joint is there. So here number of joints is 4, number of elements also 4. Joint A, joint B, joint C and joint D. And number of elements, this is 1 and this is 2 and this is 3 and this is 4. So what is this truss? So here number of joints is equal to J is equal to 4 and 2J will be 8. And what is number of members? Number of members here is equal to 4 and M plus 3 is equal to 4 plus 3 is 7. So you can easily understand 2J is more than M plus 3. 2J is more than M plus 3. So it is not forming rigid truss. It is forming under rigid truss or collapsible truss. Under rigid truss or collapsible truss. If you apply any load on this truss, immediately this truss will collapse. This truss cannot bear loads. If you apply any external load, this truss will collapse, or because of its own weight, it may collapse. So we never design under rigid truss, right? So this is very dangerous, man. This is collapsible truss. And one point you have to understand, I may give a truss like this and I may apply a force maybe 100 newtons, man, right? I may ask you, what is force carried by member AB? Or what is force carried by member AD or member CD, like that? What is your answer? When I apply this load on this truss, immediately this truss will collapse. After collapsing, what is load carried by any member, man? So this is a collapsible truss. When you apply this load, no member will carry any load, man. The entire truss will collapse. And after collapsing, what is load carried by each member? Definitely it is 0. So load carried by any collapsible truss, or you can understand like this. Load carried by any member of collapsible truss is 0. So this point you have to understand. In GATE exam, they may give number of trusses, man. They may give a truss like this with all dimensions. They may ask you what is load carried by member AB. So first you have to examine whether given truss is collapsible truss or non-collapsible truss. If it is collapsible truss, I should say load carried by each member is 0. If it is non-collapsible truss, then you have to examine, you have to find it by using various methods like method of joints, method of sections, or graphical methods like that, right? So since it is collapsible truss, load carried by any member will be 0, right? Okay. Now I may add one more member, man, right? I may add one more member here. Now number of members is 5. So what is this? So please, I hope you copied previous example. Now this is new example, man, right? New example. If anybody didn't copy this, please copy, then I will take up this, right? So you might have drawn this diagram without member 5. Have you drawn this? So draw this and write all these things. Finally conclude given truss is under rigid truss or collapsible truss. Right up to this point, then I dictate one sentence. So the given trusses under rigid truss or collapsible truss, then write this important point. Load carried by any member of collapsible plane truss. Load carried by any member of collapsible plane truss is 0. In this truss, load carried by any member will be 0 because when you apply this load, this truss will collapse. After collapsing truss, what is load, what is member, man, right? So this is collapsible. Now let us examine another example. I am adding one more member to this truss. This is 5. Here j is equal to 4, number of joints is equal to 4, but number of members is equal to 5 here. And 5 plus 3, 8. And hence 2j is equal to m plus 3. So this is definitely rigid truss or perfect truss. Since 2j is equal to m plus 3, the given truss is rigid truss or perfect truss. Rigid truss or perfect truss. And don't worry about either this joint is binary joint or ternary joint or unary joint, something like that. That concept is in theory of machines. Currently we are in engineering mechanics. In engineering mechanics, in plane trusses, joint means only joint, man. Don't worry about whether it is binary joint or ternary joint or quaternary joint like that, man. Joint means joint only. So this is a joint. About this joint, any number of members could be connected. Okay, right. Let's move to another example. Please copy this, man. Then I take up another example. Another example. Okay. So I may add one more member here. I call this member as X. So this is member 5. Here no joint, man, right? Here there is no joint. One member is like this. Over this another member will be there. Okay. So here number of joints is again 4. But number of members is 6. M plus remains 9. So here 2j is less than m plus 3. 2j is less than m plus 3. Please copy. It is forming over rigid truss. It is forming over rigid truss. Over rigid truss. In over rigid truss, we are using members more than required. You might be using one extra member than required. It is required only 5 members, you are using 6. So it is not required to use 6. 5 is enough, but you are using 6. Over rigid truss, you are using members more than required. More than required in over rigid truss. Okay, so it is forming over rigid truss. Right? Okay. So this is regarding under rigid truss, over rigid truss, and perfect truss or rigid truss. Right? Okay. Now, to perform analysis of truss or plain truss, we can use 3 different methods. So you may first write analysis of plain truss, analysis of plain truss, analysis of plain truss. By using 3 different methods, we can perform analysis on plain truss. So first is method of joints. Method of joints. Second is method of sections. Method of sections. And third is graphical methods. Graphical methods. Third is graphical methods. You can use method of joints, method of sections, and graphical methods. So one by one we study. Of course, in GATE exam we never use any form of graphical method. We are going to use only method of joints and method of sections. But before learning what is method of joints and method of sections, we should understand 3 shortcuts, man. There are 3 shortcuts while performing analysis on plain truss. Many of the times, without performing any analysis, you can understand load carried by a particular member by using these shortcuts. These shortcuts are very, very handy, man. So half of the times in GATE exam, you can predict answer in plain trusses by using these shortcuts. Remaining half of the times you have to use either method of joints or method of sections. So most of the times in GATE, they are giving simple questions, and those simple questions could be solved by using following shortcuts, man. So first point I already dictated, but again I will dictate. First point, or you may write shortcuts. After dictating shortcuts, after explaining shortcuts, I will go to method of joints, thereafter method of sections. Shortcuts. First shortcut, force carried by any collapsible truss is 0. Force carried by any collapsible, force carried by any member. Force carried by any member of collapsible truss. Force carried by any member of collapsible truss is 0. If a truss is given, try to examine whether it is forming collapsible truss or non-collapsible truss. If it is collapsible truss, definitely load carried by any member of collapsible truss is 0. I already explained some 5 minutes back. I took one example of collapsible truss or under rigid truss and I explained there. Right? This is first shortcut. Second shortcut. Second point. If any 2 members, if any 2 non-collinear members, if any 2 non-collinear members, if any 2 non-collinear members are joined by a pin joint without any external load, at the joint, or without external load at the joint, load carried by those 2 members is 0. Load carried by those 2 members is 0. For instance, here I am drawing one truss, man. Right here one truss is there. So here maybe a pin joint is there, here another pin joint, but it is put on roller support like this. An example here. So this is A, this is B, this is C, this is D, and this is E. This is first member, this is second member, this is third, this is fourth, this is fifth, and this is sixth and seven. 6 and 7. All of you may copy this diagram, man, right? These shortcuts are very handy in GATE exam. Within seconds you can predict answer for many of the problems in GATE. So copy this. Here a plain truss is presented. A plain truss is presented. Observe joint C. Okay, somewhere here load is applied. So here a load of 100 newtons is applied here. Maybe here a load of 50 newtons is applied, right? But observe joint C. At joint C, only two members are connected. Only two members are connected. Are they collinear? At joint C, member 6 and member 7 are joined. Only two members are connected. And member 6 and member 7 are collinear. They are not collinear. So, two members are connected by a pin joint which are not collinear. And at joint C, any external load is there? No external load is there at joint C. So, if any two members are joined by a joint which are not collinear, if no external load is acting at that joint, load carried by those two members will be 0. Load carried by member 6 will be 0, member 7 also 0. So this is very handy shortcut, man, right? When only two non-collinear members are joined by a pin joint without external load, those two members carry 0 load. So physically, member 6, member 7 are present, but they are not carrying any load. They are waste members, man. They are not carrying any load. Simply while performing analysis, I can neglect these two men because they are not carrying any load. Just I ignore those two members. Just remove those two members. Whichever member doesn't carry load, just remove that member, man. So physically it is present, but it is not bearing any load. It is redundant member, man, right? This is redundant member or waste member. Wastely you are putting that member. So in no truss, extra member should be there, right? By putting extra members, you don't get any benefit. Unnecessarily cost of truss will increase. So don't use over rigid truss. Rigid truss is enough. Okay, this is one shortcut. Next shortcut, third shortcut is if three members are joined by a pin joint, if three members are joined by a pin joint without any external load, comma, if two of those members are collinear, if two of those members are collinear, the third non-collinear member carries 0 load. The third non-collinear member carries 0 load. This is very, very handy shortcut, man. One example here. So I may form a truss here like this. Here one support is there, and here another support is there, and this is one member, again one more member, again one more member, and again one more member like this, So a truss is formed like this. A truss is formed like this. Maybe somewhere here I am applying load of 1000 newtons. This is joint A, this is joint B, this is joint C, this is D, this is E, this is F, this is G, H, I, J, K, L. Like this, a truss is formed. So all of you copy, man. So we try to understand the third shortcut. The third shortcut. So here a truss is formed with number of elements, man, right? And this truss is carrying an external load of 1000 newtons at joint D. Let us try to examine which member carries zero load. For that, I may give numbering also. This is first member, this is second member, this is third member, fourth member, fifth member, sixth member, this is 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 and 21. Okay? Give numbering also, man, right? So that you can easily understand. I hope you copied. Now let us try to examine which members carry zero load. Observe joint B. Observe joint B. At joint B, 3 members are joined without external load. At joint B, no external load is acting. Only 3 members are acting, 3 members are connected. Member 1, member 2, member 13. 3 members are connected at joint B without any external load. Out of these 3 members, 1 and 2 are collinear. Member 1, member 2 are collinear. Then what my shortcut is saying, man? Out of these 3, if 2 members are collinear, the third non-collinear member carries zero load. Out of 1, 2, 13, member 1, member 2 are collinear, member 13 is non-collinear. Load carried by that non-collinear member is 0. Now come to joint L. Actually at joint L, 4 members are connected, member 12, member 13, member 14 and member 11. 4 members are connected at joint L. But out of these 4 members, 13th member doesn't carry any load. If any member carries zero load, just ignore presence of that member. Physically it is present, but it is not bearing any load. just ignore that member is not there. So at joint L only 3 members are connected because member 13 carries 0 load. Just ignore presence of this 13th member. 13th member is not there. If you neglect this, only 3 members are connected at joint L. At joint L, only 3 members are connected. Out of these 3 members, member 11, member 12 are collinear. Member 11, member 12 are collinear. 14th member is non-collinear member. 14th member is non-collinear member, and joint L doesn't carry any load. That means 14th member carry 0 load. If 3 members joined by a pin joint, if out of these 3, if 2 members are collinear, the third member will carry 0 load. If no external load acts at that joint, that point you have to understand, man. If external load acts, then the member doesn't carry 0. Alright. So now come to joint C. Come to joint C now. Actually at joint C, no external load is acting and 4 members are joined. Member 2, member 14, member 15, member 3. 2, 14, 15, 3. 4 members are joined at joint C. But out of these 4, member 14 doesn't carry any load. Member 14 is carrying 0 load. So ignore presence of this member. Actually this member is there. Since it is carrying 0 load, just ignore presence of that member. That member is not there. If you ignore this member 14, then only 3 members are joined at joint C. Only 3 members, member 2, member 3, member 15. Out of these 3 members, 2 and 3 are collinear. Out of these 3 members, 2 and 3 are collinear. Then the third non-collinear member will carry 0 load. That means it also carry 0 load. Okay. Now come to joint K. At joint K, there is no external load. External load is only applied at joint D, man. About all other joints, no external load. Right. So here, no external load is acting. No external load is acting and 4 members are joined at joint K. But out of these 4 members, member 15 doesn't carry any load. Just ignore member 15. Since it doesn't carry any load, just forget about member 15. If you ignore member 15, only 3 members are connected at joint K. Only 3 members are connected at joint K. Out of these 3 members, member 10, member 11, these 2 are collinear. And what is non-collinear member? Member 16. About joint K, 16th member is the non-collinear member. So this member also carries 0 load. Similarly, on right also we can have 0 force member. So this is 0 force member, this is 0 force member, this is 0 force member, this is 0 force member. Okay. And don't do mistake, man. You know, sometimes students may get confusion about joint A. About joint A, how many members are connected? Member 1, member 12. But here support reaction will come. RA will come. So RA will come like this, man. You know, about joint A, load is acting. Which load? RA is acting. If this RA is not there, definitely these 2 members also will get 0 load. If any 2 non-collinear members are joined without any force, those 2 members will carry 0 load. Second shortcut, man. Okay. So use these 3 shortcuts, man, right? Again I repeat, force carried by any member of collapsible plane truss is 0. And second, if only 2 members are joined, if only 2 non-collinear members are joined at a joint without any force, those 2 members will carry 0 load. And third shortcut, if 3 members are joined by a pin joint without external load, if 2 of them are collinear, the third non-collinear member carry 0 load. So by using these shortcuts, most of the gate questions you can do. You know, surprisingly, in most of the gate problems, they may give you a truss like this, and they may ask force carried by a particular member, 10th member or 11th member, like that. And surprisingly, in most of the gate questions, the answer is 0, man. The answer is 0. If there is no negative marking, and if you don't know how to solve the given truss problem, then you give answer of 0. There is no negative marking, just put 0, man, right? Learn concept, man. You know, comically I am saying, right? Learn concept and try to do problem. Try to be sure, right? But if you don't know anything, you can assume the answer is 0, man. So in most of the gate problems in trusses, the answer is 0, right? So nothing works out, just assume answer is 0. You could be correct, man. 50% probability is there. Your answer could be correct. So these are the shortcuts. Now we start doing some numericals from plain trusses, okay? Plain trusses. So all of you may refer your classroom workbook, numerical number 23. Numerical number 23. Numerical number 23. So here a structure is given. So this is a pin joint, and this is again a pin joint. So here an external load is applied. This is B. This is also a pin joint. This is A, and this pin joint is C. This is 1. This is 2, and this is treated as 3. Okay, so here a plain truss is given. A plain truss is given like this. This question came in gate 2001, right? So this is 23rd numerical, and this question came in gate 2001. It is a multiple choice question, man. So they ask like this. Member AB carries bending load. Member AB carries bending load. Member BC carries bending load. Both AB and BC carry bending. Option D, neither AB nor BC carry bending load. We already know, member AB carries axial load, member BC carries axial load. We did this kind of problems already in statics by using method of rectangular components. So member BC carries tensile force, member AB carries compressive force. Neither member AB or BC carry transverse load or bending loads. These are made with axial force members. AB and BC carries only axial forces. These are bar elements. These are not beam columns. So AB will not bend, BC also will not bend, because all joints are pin joints, man. All joints are pin joints. So definitely the structure behaves as if it is a plain truss. So all members of plain truss carry only axial force, no other force, man, right? Okay. So please copy. Let's move to next numerical. Let us do 24th bit. So for this question, answer is neither AB nor BC carry bending loads, right? Okay. You may refer numerical number 24. A truss has total number of members 11. A truss has total number of members 11. Number of joints is equal to dash. Number of joints is equal to dash. The given truss is rigid truss or perfect truss. The given truss is rigid truss or perfect truss. So we know in all rigid trusses 2j is equal to m plus 3. Here m is 11, 11 plus 3 means 14. 2j is equal to 14, j should be 7. So if you are lucky, this kind of questions also can come in gate, right? So number of joints in this truss is 7, right? So please copy. So number of joints in the given truss should be 7 to make the truss perfect truss. Then let us do another numerical, 25th numerical, 25th numerical. In a truss, number of members is equal to 6, or number of joints is equal to 5. Number of members is equal to 6, number of joints is equal to 5. So obviously 2j means 2 into 5 10, m plus 3 means 6 plus 3 9. Here 2j is more than m plus 3. It is definitely collapsible truss, man. It is not rigid truss. The question is like this: how many more members are required to make it as perfect? How many more members are required? How many more members are required to make it perfect truss? In perfect truss, 2j is equal to m plus 3. So here 2j means 10. 10 should be equal to m plus 3. 10 should be equal to 10 plus 3, m plus 3. Here what is m? 6. 6 plus 3? 9. But we have to get 10 here. For getting 10, what is value of m? M should be 7. When m is 7, the given truss becomes perfect truss or rigid truss, man. But how many members are there? Only 6 are there. When m is 7, the truss becomes perfect. How many more members I have to add to this truss to make this truss as perfect truss? Already 6 are there, but I require 7 here. So one more member I have to add. By adding one more member to this collapsible truss, I can make this collapsible truss as perfect truss or rigid truss, man. The answer is one more member should be added. One more member should be added to make this collapsible truss as perfect truss. The answer is 1. I have to add one more member. Okay, so this is end of this session. In coming session, we will do few more numericals on plane trusses. So until next session, have a great day. Thank you for listening this lecture. Thank you.